As we continue to look at how the Earth is always changing and dynamic, you're going to see some information that you probably remember from before. One of the concepts is continental drift. So you might remember the word Pangea, and I'm hoping you remember the name Alfred Wegener. Remember, he was the scientist that proposed the hypothesis that the continents were drifting or plunging, moving their way through the oceans. And he said, hey, look at the shapes of the land. Abraham Ortega has already thought of that, but he pointed it out again. And then he added new evidence. He said there are matching fossils, there's matching rocks and mountains. There's even evidence of different climates, like coal deposits where they shouldn't be, and glaciers where there are no glaciers now. The evidence of the past started to show the connection in the continents. But Wegener was kind of laughed at because he couldn't explain the mechanics behind this. He couldn't explain why the continents were drifting. What Wegener and other scientists didn't know was that continental drift was just a small part of the puzzle. It was a very important part to the common understanding of plate tectonics. So plate tectonics is the theory that we currently subscribe to. And what it did was this theory says that our planet is broken up into these different plates. And the lithosphere, or that outer layer of the planet, is actually in motion. So all of Wegener's data and observations and understanding were right on. But then, as time developed, plate tectonic theory developed because there were other scientists that added their information to the mix. Harry Hess and Robert Dietz were important for studying seafloor spreading. Drummond Matthews and Frederick Vine were important because they looked at magnetic patterns in the seafloor. And you all should remember my favorite scientist, Marie Tharp. She was the oceanographer mapping genius that put together the earthquakes and helped map out the Mid-Atlantic Ridge. And then in 1975, there was a research vessel called Alvin, and this underwater crew went down to the mid-ocean ridge and was able to view some of these areas that were previously unseen. And so with plate tectonics, there is all of this data that shows the seafloor is moving from these mid-ocean ridges, and where they move out, there are other areas of the plates that are getting subducted near other areas. The ocean floor also has these magnetic, like reversal rocks, where you can see the organization of minerals are actually oriented differently to show the north and south pole flipping and switching over the years. And earthquake and volcanic data has been collected over time to show where these plate boundaries are. Now, even though we have all this data and we have all the information showing how the Earth is in motion, some scientists are still debating and questioning the exact process that causes plate tectonics. We know that it has to do with the mid-ocean ridges and pushing outward, but we also know that in the mantle there are these convection currents that help move the tectonic plates. And third, we have areas of the mantle that are being pulled underneath the continental crust. And so scientists are still debating and researching and looking at what are the mechanics involved here. And we get many benefits from that research. We find mineral deposits, and we know about areas that have high seismic activity, so we can go ahead and develop houses that are seismic safe buildings that prevent damage from earthquakes. So this is a really, really good example of how science understanding builds and develops over time. Alfred Wegener had some amazing ideas with continental drift, but it was just a hypothesis. We actually needed more information and data and scientists to be involved to get a better picture of how our planet is moving. Plate tectonics is the current theory, but we're still researching. So different pieces of information in the past may get adjusted and changed as we learn more.